All right, in today's video, we're going to be talking about bad geometry. We're going to talk about different types of bad geometry. We're going to talk about how we can locate the bad geometry and how we can, different ways we can approach fixing the bad geometry. Now, I want to preface this by saying that this is a topic that not everyone may be on the same page about in terms of what they consider bad geometry and good geometry. This is very much a sort of circumstantial thing, right? A lot of it depends on the circumstances. For example, if you're 3D printing something, or if you're modeling something for a video game, or if you're just high poly modeling something for like a cinematic or something like that. So there's going to be different opinions. Right. This is just sort of like a simplification of what I've learned through my, many years 3D modeling and teaching 3D modeling, and just sort of like the basics of what I consider bad geometry. But I don't want it to seem like that these things are like forever written in stone rules. Right. There are exceptions to everything. So, you could take this with a grain of salt, but this is definitely what I consider to be bad geometry and how to approach bad geometry and possibly get rid of it if you can. So with that said, I typically break down bad geometry into two different categories. We're going to talk about non-manifold geometry. So this is geometry that your software is going to say is not good, right? It's like Maya or Blender or whatever software that you happen to be using. In this case, we're using Maya. But this is geometry that your software is going to have issues with, right? And then there's the other category, which is messy geometry. This is geometry that your software may not necessarily have issues with, but it's hard. It's more difficult for you to work with as a 3D modeler. It may cause some weird things, weird artifacts in your shapes. It's difficult to create edge loops. It's things that you want to be mindful of as a modeler, and you want to sort of keep to a minimal, or you want to minimize these things as you're modeling just to make life easier for you. And it's not unheard of for both of these categories to kind of create issues in the other category. So for example, a lot of times non-manifold geometry can lead to messy geometry, and messy geometry can lead to non-manifold geometry. So they're not necessarily mutually exclusive. But I tend to group these into these two different categories: non-manifold geometry versus messy geometry. So let's talk about what's considered non-manifold geometry. And the first one right off the bat is a bit controversial because I think a lot of people would not really consider n-gons as non-manifold geometry. I kind of consider them as non-manifold because there's a lot of issues if you have n-gons. For example, it's difficult to do UVs if you have a lot of n-gons and things like that. So while some people would argue that there are use cases for having n-gons in your geometry or your models, I would consider that being more of an advanced take, and more of an advanced user would have those opinions. So if you're just learning 3D modeling, you should just concentrate on just trying to get rid of all of your n-gons, right? What is an n-gon? An n-gon is a polygon or a face that has more than 4 sides, any number more than 4 sides. So n just stands for any number, basically, right? So let's look at some examples of n-gons, right? So this is an obvious example right here, this face that we have right here on this cube. And if we are to look at the edges, right, we have 1, 2, 3, 4, 5, 6, 7. I think there's actually 8 there, but there's 8 edges around this one face. So that's an obvious example of an n-gon. Whereas what we consider quad or, good geometry is usually we want to try to keep things in quads for the most part. Only has 4 edges around it, right? So this is a very obvious example of an n-gon. Now let's look at a not so obvious example of an n-gon, right? So if I were to select this face and look at this face, it looks square, right? It looks like it has 4 sides. When you're dealing with n-gons, you can't base your sort of when you're looking for n-gons, you can't look for just the amount of sides you have, right? So like a side is a very sort of ambiguous term when we're talking about this. What we're talking about are the number of edges, not necessarily the number of sides, right? Because a face like this looks like it has 4 sides. It looks like a quad. It looks like it's made up of 4 sides. But if we were to count the edges here, right, it has more than 4 sides. Now, I explain in a lot of my videos why n-gons are problematic. Basically, it's because your geometry can't sort of interpolate, or your software doesn't know how to interpolate your geometry the way you want. It's sort of chaotic. It's not as controllable as like a quad or a triangle is, right? In terms of how that geometry sort of folds. And in a lot of cases, like for example, when we're doing UVs, like UV unfold, a lot of times it just won't work if you have n-gons. Some game engines like Unity or Unreal, if you bring in a model that has n-gons into that game engine, it will just not display the n-gons. They'll just show up as holes. So while there are some, what I would say, advanced use cases to where you can leave n-gons in your model, as a beginner, as a learning, as a student of 3D modeling, you should be diligent and just try to get rid of all n-gons. Later on, when you become a more advanced user, you can experiment with possible scenarios of where an n-gon would be good to use, right? But in most cases, they're bad. You want to avoid them. Another not so obvious example of an n-gon are right here. So if I know these are n-gons because I sort of made them, but all of these faces here are n-gons, right? So if I go to face mode, all of these here are n-gons. They don't look like n-gons. They look like quads, right? They look like they have 4 sides. But if I go to vertex mode and I see this little vert right in the middle here, right, that's making this what appears to be a quad an n-gon. So it has 1, 2, 3, 4, 5, 6 sides. So that is an n-gon. How this is created, just to kind of show you really quick, is whenever you select an edge loop like this and you just hit delete, it will delete the edges. But if I go to vertex mode, the verts remain there. So as a rule, whenever I'm deleting edges and I want to get rid of the edges and the verts, I do Control or Command delete, and that will delete the edges and the verts as well. So, in a nutshell, that is what an n-gon is. An n-gon is any face, any quad, polygon that has more than 4 sides to it. The next thing we'll talk about here is a lamina face. So a lamina face is basically 2 faces that are sandwiched together. This is another thing that gets created by accident very often. And it's something that this one in particular is kind of hard to find unless you know that you've created it by accident somehow. And basically what a lamina face is, again, it's just 2 faces that are sort of like connected at all 4 edges, right? So it's sort of like laminated together. So if I were to take these two faces here that are currently one object, and I would go to my target weld tool, and if I weld all of the corners of this face together, we're gonna see like this weird sort of flickering scintillation thing happening. And basically this is what's called Z-fighting. So Z-fighting is when two faces are so close to each other, your viewport doesn't know which one to show. So that's called Z-fighting. And this is basically a lamina face, right? So it's two faces that are welded together. If I just grab a vert and I move the vert around, both faces will move, right? But if I go to face mode and I select a face and hit delete, it deletes one of them, the other one's still there. So that is basically what a lamina face is. So lamina face is two sort of polygon faces that are welded together or laminated together. Next example we're going to talk about is a stray vertice. So here we have this stray vertice that I made, and it's just a single line sort of jutting out of our model. And we have this vert here that if I move around, it's just kind of moving an edge around. This is another sort of just like accidentally created thing. As you're modeling, you're going to create these things. You're going to get them accidentally. I get them accidentally all the time. And it's just sort of too important to know how to sort of fix them whenever you see them. But basically a stray vert could be something like this. It could just be a line jutting out of your model with an edge on the end or a vert on the end. If I hit delete, that doesn't delete. It could also just be a vertice floating somewhere out there by itself without an edge attached to it. Typically, if I want to fix these, the way that I would fix these is I'll go up to my target weld tool, which is right here. And this is in my personal little mega shelf, but let's go over to our modeling shelf. So in our modeling shelf, it's way over here. And then what I do is I just weld it to an existing vertice, right? And that generally seems to solve the problem. But that's what I would consider a floating or a stray vertice like that. The next one being T-faces. So a T-face is any sort of edge, right? So we have an edge here that actually has more than two faces attached to that edge. So this edge in particular has a face attached here, face attached here, and a face attached here, right? So if I were to select this edge and move it around, all three of those faces sort of move around with that edge, right? This is non-manifold geometry. This is something that your software doesn't like. And it's not something that should exist in the real world, right? So like if we're thinking about our polygons of like as being like the outside or inside of an object, if we have a face like this attached to it, then then our object basically has more than one outside and more than one inside, right? So like, for example, like this face would be outside, this face would be outside, this face would be outside, this face in this direction would be the inside, right? And then on the inside of the cube, this is the inside. So this is just sort of like confusing geometry for our software. And this is definitely considered non-manifold geometry. Now, I do want to say that these are not the only types of non-manifold geometry. There are more types of non-manifold geometry, probably, non-manifold geometry that I don't even know the names of. There's something called valence faces as well. So these are not the only types of non-manifold geometry. There's other types of non-manifold geometry. These are just sort of, for me anyway, the most common examples of non-manifold geometry. Now, how do we find non-manifold geometry? And I want to talk about this before we get into what we consider messy geometry. We're going to find our non-manifold geometry with a tool called Mesh Cleanup. So if we go up to our modeling menu set and go to Mesh Cleanup Options, we're going to get this box that pops up here. So let's actually select our object that we have here. And now the settings that I use for this Mesh Cleanup tool is I like to do select matching polygons. Do not do cleanup matching polygons, and I'll talk about that in a second. So we're going to go select matching polygons. We're going to go faces with more than 4 sides. So these are all your n-gons. So this is going to select all of your n-gons. And then we're going to choose lamina faces and non-manifold geometry, right? So with those options selected, and I hit cleanup, it's going to select for us all the problematic geometry, right? So it selects our n-gons. It also selected where our T-faces are and our stray vert as well. So then we can choose how to clean them. Now, typically what I like to do, especially if it's a very complicated model, is I will assign a material to these. So I'll go in, I'll right click, and I'll go down to assign favorite material and just do a standard surface. And then make it red or something very visible. And then I can also change this to something like n-gon material. Right, so that way I can click off of this. I can say, okay, these are my n-gons. These are the areas that I need to fix on my model. And I'm just going to get rid of this guy down here for now. Okay, so the first one is going to be a very easy one to fix. That's all these vertices here, making all of these n-gons. So those are very easy to get rid of. And what you can do is you can just select all of those and hit your delete key. And what happens whenever you do that is it's only going to delete vertices that are connected to 2 or fewer edges. So for example, this vertice right here, only connected to 2 edges. So if I hit delete, it will delete that vertice. But if I select this vertice, which is connected to 4 edges, nothing is going to happen. It's not going to delete that vertice. So if I really want to go in and fix those verts right there, I'm just going to select them all and hit delete. And it's going to delete all those sort of vertices that are unneeded, right? And now what I can do is I can reassign my existing standard surface material. I can do mesh cleanup again. Our settings are still saved in there, so I'll just go mesh cleanup again. And then it'll select our n-gons again. I can right click, assign existing n-gon material, and now I know where my n-gons are, right? So very easy way to just sort of keep track of where all your problematic geometry is and fix them. Now, another way we can fix our n-gons is to use our multi-cut tool, right? So for example, this guy here, or this one over here, I can just come back over here and I can redraw using our multi-cut tool. I can redraw those areas that were deleted out of it. And now I have all quads there. And once again, if I want to reassign my existing standard surface, do mesh cleanup again, and reassign my n-gon material. There is my n-gon, right? Again, very easy to fix this with our multi-cut tool. I can just kind of go in, and even if I do something like this, right, that still keeps it to all quads, right? So this is a quad, 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 right? So that's one way to go about fixing your n-gons or your non-manifold geometry. Now, we already kind of talked about how to fix the stray vert. We can use our target weld tool and just weld that to an existing polygon. We could do that here as well, right? We could take our T faces and just weld those down to an existing polygon or an existing vertice, or we could just delete them, right? In a lot of cases, rather than trying to figure out how to solve an issue with your geometry, it's just easier to delete it and remake it, right? That's the simple truth. You're going to save time a lot of times just by recreating your geometry than racking your brain trying to figure out how to fix it, right? That's sort of my philosophy. If any part of my model is giving me a particularly hard time, I typically just delete it and I remake it. It may seem counterintuitive, it may seem like a waste of time, but again, in the long run, it's going to be much quicker for me to just recreate it the correct way, being careful about not making the mistakes I did the first time, rather than spending hours trying to figure out why this one edge won't delete, right? Or why this one edge is showing up as bad geometry. 9 times out of 10, it's way easier to just delete the geometry and recreate it than try to figure out why it's bad. Okay, so I'm going to undo this here to back where we have sort of just like a messy piece of geometry like that. And now let's talk about why we don't want to do mesh cleanup and why I don't like to do cleanup. Now, whenever you choose cleanup, what's going to happen is Maya is going to fix, or your software of choice, if you have a similar tool in Blender or something like that, your software of choice is going to choose how to clean up that bad geometry, that non-manifold geometry. And when you do that, it's going to create messy geometry, which we'll talk about here in a second. So the reason I don't like using cleanup, and I'll just do select matching polygons, so then I choose how to clean them up, is because oftentimes when you do cleanup, Maya will create messy geometry, which in a lot of cases is much more difficult to deal with than non-manifold geometry. So let me show you an example of that. So if I then just come in here and hit cleanup, we're going to see a lot of weird things happening here. So the first thing being, let's just set this back to our standard surface. The first thing being is that now we have this very weirdly triangulated stuff, right? So like this has created like all this weird triangulation. So that's my first example, or my second example there of messy geometry is over triangulation, right? So like everything's sort of like just oddly triangulated now. This is problematic because now if I want to come in with my multi-cut tool and create an edge loop, I cannot create an edge loop through that area because it's got these bad triangles in it. So that is the first sort of messy geometry that was created from doing cleanup rather than trying to figure out how to clean it up myself. The other thing it will tend to do is separate or cut apart your geometry when you hit cleanup, which is also bad. So for example, where our stray vert is here, if I go to vertex mode and I start selecting these verts and moving them away from each other, you can see that it actually cut up that whole area. So now we have a big hole in our geometry where that stray vert is, right? And now this becomes much more difficult to deal with rather than just having that one vert that we could target weld to another vert, right? Same thing with this, right? This where we had these T faces and we chose cleanup in our mesh options. And it did the same thing, right? So it went in here and actually cut up the geometry. So now we have like this geometry that's all sort of like cut apart into different pieces, right? And now this becomes much more difficult to deal with rather than just selecting it and us fixing it ourselves. So as you're working and as you're learning to use that mesh cleanup function, let me just undo back to where we were here. as you're working and as you're learning to use the mesh cleanup function, I highly recommend to not let Maya clean up your geometry, because it's just going to create messy geometry. And while it's no longer going to be non-manifold geometry, right? So we choose mesh cleanup, it's going to get rid of all the non-manifold geometry, but in its place, it's going to create messy geometry. So you're much better off just trying to figure out how to fix it with the tools that you have. There's not really a click and fix type thing, right? You're going to have to fix it, and then you're going to have to fix it, right? Maya's going to fix it, and then you're going to have to fix what Maya tried to fix. So it's much easier if you just fix it yourself, right? That's sort of the attitude that you want to have. So again, messy geometry is something that may not necessarily be considered non-manifold geometry. It may not be bad in Maya's eyes, but it is bad in organizational ways and just sort of like housekeeping ways. It's going to be more difficult to work with if you have this bad geometry, or messy geometry. So let's talk a little bit about messy geometry. The first one is one that happens a lot. And this is just a double extrusion. So if we grab a face here, and an easy way to extrude in Maya is just holding down Shift and clicking to extrude out. You also have a Shift or an extrude function or extrude tool up here. Now, if I hit that extrude tool, and I move that geometry, extrudes that tool out or extrudes that face out. If I hit that extrude tool and then click off of it, it's going to look like nothing happened, right? It's going to look like I didn't actually extrude anything. However, if I did just grab that and move it out, that is an extruded face. So this is what I consider a double extrusion. This is where, you may have, and you may do this multiple times without realizing it, right? So like currently select that face and move it out, it's extruded. Maybe I hit it and then accidentally clicked off of it. And then I'm going to go and click it again and click extrusion again. And every time I do that, I'm extruding that face, right? Even though it doesn't look like it's being extruded. So what happens is we just have like a buildup of these verts, right? So like all this stuff is just sort of building up and creating a huge mess here because we just keep extruding and extruding and extruding. So that's a very common sort of messy geometry are these double extrusions. So be very careful about using extrude. And when you do use extrude, make sure that you either actually extrude the face that you want to extrude, or if you happen to click off of it, undo that. So it goes back to not being extruded, if that makes sense. All right. So, just be careful about extruding. Extruding is a very powerful tool. So it's something that you're going to be using a lot. Just be very careful with it, right? Now, we've already talked about over triangulation, and that's just getting like bunches of triangles in your model. This is a very circumstantial thing, though, especially if you're talking about like low poly modeling versus high poly modeling. When you're doing low poly modeling, it's very much okay to have just triangles all over the place. And that's because at the end of the day, everything gets turned into a triangle. Every quad turns into two triangles. At the end of the day, everything gets triangulated. However, it's very difficult to work with a triangulated mesh. So the reason we want to keep things in quads as we're working is because it's much easier to work in quads, right? We can add edge loops. So for example, if once again, if I just go to mesh cleanup and I let Maya clean up my model here, we have a bunch of triangles now, right? So now I can't do things like add in an edge loop, right? So if my edge loop's going to stop, if I want to add in an edge loop right around here in this area, I can't do that because it's all triangulated now. So this is, while I do consider this messy in some situations, in other situations, it's completely fine. It just depends. It's very circumstantial, like I said. If you're doing low poly modeling, if you're doing like a game model, having some triangles all over the place is not going to be that bad, especially because at the end of the day, everything's going to get triangulated anyway. It is a lot easier to work in a quadrangulated mesh, not a triangulated mesh, though. So try to stick with quads, but you can have triangles occasionally. Whereas when you're doing like high poly modeling, you pretty much want to have as few triangles as possible. And when you do have triangles, you want to hide them. So for example, if you're modeling a character, you want to hide your triangles like behind the ear or like in the armpit or something like that, where they're not going to be seen. And again, it's just easier to add edge loops and things like that with triangles, without triangles, with quads, I mean. So, while I consider this messy, it's also a very circumstantial thing. And there are some situations where having lots of triangles is fine. But for the most part, if you see something like this where you have mostly quads, but then you have like this weird triangulated section of your model, that's typically messy, and that's going to cause issues for you. It's going to be difficult to work with that geometry because it's all triangulated. Now, the other example of messy geometry is poles. A pole is basically any vertice that's connected to 5 or more edges. And I say 5 or more edges because if we look at, for example, like this vertice, it's only connected to 3 edges, right? 1, 2, 3. And this vertice is connected to 4. 1, 2, 3, 4. This one is connected to 1, 2, 3, 4, 5, 6. So that would be considered a pole. And poles, they're not as huge of an issue if you're doing low poly modeling, but if you're doing high poly modeling and you're smoothing your geometry will kind of stretch in a way that will create this weird look to it. So you generally want to try to avoid poles. So let me show you an example. If I just create a sphere here, so we got a sphere, and obviously by default, a sphere is going to have a big pole on the top and bottom. That's where it gets its name, right? So North Pole, South Pole. Now, if I take this sphere and I hit 3 on my keyboard to do a smooth preview, and let's turn off our wireframe, and let's add a new material to this. And I'm just going to make it a little bit darker and a little shinier so we can kind of see what's going on here. Now, whenever I start to hover over the pole area, we get this weird sort of star pattern, right? This is like pinching that's happening because of that pole. So while poles are generally okay to have on like a low poly model, when you're doing high poly modeling or subdivision modeling where you're planning to smooth your mesh at some point, poles can generally create these weird sort of stretched artifacts in your geometry. So this is something that you kind of want to avoid if you can. It's more of an issue in organic models like character models or creature models, or things that have lots of different forms and shapes on top of it. It's not so much of an issue with like hard surface modeling because usually those poles are going to fall on like flat areas where, the geometry is not going to stretch in a weird way. But that's what a pole is. A pole is just any vert that has more than 5 edges attached to it. All right. So the next thing we're going to talk about is a little bit more nuanced, and it's kind of circumstantial depending on if you're modeling like low poly or high poly, or it just depends on your scenario. But this is more of like a high poly modeling thing. But that's having a balanced or unbalanced topology is messy. And that also sort of goes hand in hand with global edge flow versus localized edge flow. So an example of that would be this cube here, where I have this sort of cut, sort of circular cut or like oval shaped cut cut into it. And in order to make this sort of round edges, I've added all these edge loops, and they go all the way around throughout the model. This is what I would consider globalized edge flow. This is edges that are just going all the way throughout the entirety of your model, even into areas where you don't necessarily need the detail, right? So like we need this amount of detail here, but we don't necessarily need it all the way down here, right? We don't need all these edge loops like wrapping all the way down here because there's no detail down there. We only need that geometry where we need it, where we need that detail. This is also causing an unbalanced topology, right? We have nice and square polygons throughout our entire model. And then we look here and we have these really long triangular ones. So it's very unbalanced or unoptimized or very badly distributed topology or polygons. So those two things sort of go hand in hand: unbalanced topology and globalizing your edge flow, where you just create an edge loop and it goes throughout your entire model. So in this case, globalizing your edge flow is a very bad thing. Versus localized edge flow. Localized is a very good way to model because it keeps your geometry balanced and you're localizing the amount of details you need or the amount of edges you need just to the areas where you actually need them. So in this example, we basically have that same shape, right? Same exact shape here. But this one is your geometry is localized to just where you need it, right? So we don't have those edge loops wrapping all the way throughout the entirety of our model. They're just sort of where we need them to be, right? And what's really cool about this is once you learn how to do this properly, this is actually an edge loop that kind of loops around in on itself. So even if I added another edge loop in here now, it's just going to loop around on itself. So it's not going to, again, it's not going to extend throughout my entire model, right? So this is a very localized edge flow. I'm only keeping those edges and details where I need them to be, where I want those details to be. This is a good way of modeling versus this, which is an unbalanced topology, and it's a global edge flow where I have edges wrapping all the way around my model. Now, another big benefit of this is that this will make your model a little bit easier to work on because you don't have these really tightly packed edges just in areas where you don't need them, right? It's also going to lower your poly count quite a bit, right? So if I look at this model here, we're at about 1,300 tries here. So this is about 1,300 polygons, whereas this one's about 1,540, right? So this is a lot more polygons than this one is. And that's just because here we were kind of lazy and we just let our edge loops wrap around our entire model versus localizing your edge flow or localizing your topology, your edge loops, or however you want to say that. So again, this is a very nuanced sort of category here, localized versus global edge flow. But it's very important when you're talking about high poly modeling, even in some situations where you're talking about low poly modeling, it's very important. But in a nutshell, these are the things that I would consider bad geometry. Again, this isn't all the bad geometry there is. There's much more non-manifold geometry. There's much more situations where I would consider it messy or bad geometry. These are just sort of like the more common ones that I see being dealt with, and how to approach them, how to think about them, and possibly how to get rid of them. So hope you enjoyed the video. If you have any questions, or if you have another topic you'd like me to cover, please don't hesitate to comment, and I'll try to make a video for you. So until next time.